Okay, this is note video 31. It's the first video in chapter 10. So this is video number 31, chapter 10, section 1. So this chapter is all about something called conic sections. And just to give you a really brief background of what we're actually talking about, and keep in mind, I can't draw, so I'll do the best I can here. We're talking about like this 3D cone, double cone. And if you were to make slices through this cone at different angles, you get different conic sections. For example, if you took a plane, so you take a plane and you cut this cone with a plane. A plane being a two-dimensional, like a piece of paper. You could almost think really that's three-dimensional, but it's so small in terms of width that it looks two-dimensional. You cut the cone with a plane at different angles, and different conic sections are created. And here are the ones that you can get. So if you take a plane and cut it straight through here, and if you like lifted this top piece off the bottom piece and actually like looked at it, you would actually get a circle. Okay, I'm going to get rid of that green piece. Can I do that? I can't really do that. All right, if you took that same plane now and cut it this way, if you can imagine that, instead of a perfect circle, you get an ellipse, which is the mathematical name for an oval. And if you took this and cut it through, I don't even know if I can do this. Let's see. You cut it. No, that's not right. Well, you get a point if you go through there, but that's not what I'm looking for. I don't know if I can do this. I guess it would go through like this, actually. What you end up with is a hyperbola. Wow, can you guys hear my dryer in the background? If you hear a banging noise, that's my dryer. I don't know if you can hear it. If you can, I apologize because it's kind of loud. So a hyperbola, when you graph it, is two parts of a graph, and it looks like two parabolas that look like that. And so the middle of this cone would be the middle of this thing, and that is what that would look like. And then if you took and sliced just this way, one of these, boom, that's where you would get the parabola from. And there's a better picture of this in your textbook, and a parabola is just one U-shaped graph. There's a better picture of this in the textbook that we have. There's probably a good picture of it in the, remember, I can't draw, hence the bad pictures, in the textbook that's on Varsity also. But you don't really need to know any of this. I want you to have an understanding of it, though, for those of you that want to know what these actually are. This is the idea of where these conic sections come from. So there's four of them: circle, ellipse, hyperbola, parabola. We'll be talking about all four. All of them have a standard form, and that's what's needed to graph them, and a general form. And just kind of a heads up, the general form is the same for all of them. It's ax squared plus by squared plus dx plus ey plus f equals 0. It's exactly the same for all of the, well, with the exception of the parabola. It's exactly the same, but there's rules on the ax squared and the by squared and I'll talk about what those rules are for each one. So in theory, by the time we're done, you should be able to see a list of these and know which one's which. We'll talk about that at the end. All right, so the first one we're going to talk about today is the circle. It's the easiest, shouldn't take too long. I do need to talk about how to complete the square though, and that may add to the length of this video. Maybe not. Maybe I'll break it into two. I don't know. We'll see how it goes. All right, so some paper. Okay, so the standard form of a circle is the quantity of x minus h squared plus the quantity of y minus k squared equals r squared, where the point hk is the center of the circle and r is the radius. Okay, so if you're given some information, you should be able to glean some data about that circle. For instance, if you had the equation x minus 4 quantity squared plus y plus 1 quantity squared equals 25, and you were asked where is the center and what is the radius, well, there's a couple ways for you to think about answering this question. So the formula is x minus h. So the minus is already in the equation. So h equals 4. And we know that y minus k is in the equation. So this guy is actually, y has to equal a negative 1, right? Because y minus a negative 1 would make this a y plus 1. So these are actually opposite the sign that's there, if that makes sense. Because the formula is a negative, right? H is just the 4. And because this formula is a negative, then the y is actually a negative 1. So they look like they're opposite the values that are there. Now, this is r squared, right? According to the formula, it's r squared. So you're going to take the root and take the root. So r equals 5. So we now know the center is the ordered pair 4, negative 1, and the radius equals 5. Let's talk about how to graph that thing. I'm going to go grab some graph paper. We'll just plop this graph right in here. It might be a little big, but it'll do the trick. All right, so when you graph one of these, you want to start with the center. So I'm going to plot the center at 4, negative 1. That will go here. And then your radius is the distance from the center to the edge of the circle, right? You should know that. I'm just plotting it in here in case you don't. Distance from the center to any edge of the circle. So what I want you to do is go north, south, east, and west from the center point. And put 4 points on the graph. Like if you have to do these by hand, you'll be doing these mostly on varsity. So I'm going to go 5 units north. 1, 2, 3, 4, 5. So I'm going to have one here. 1, 2, 3, 4, 5. That goes off the graph. 1, 2, 3, 4, 5. See how close I was with that one on the right. 1, 2, 3, 4, 5. Now I have this cool tool that allows me to make a circle, start in the center, and go out a certain number of points. So that goes out 5. So look, I was off just a little bit. Oh, that is not even close on that edge. Well, that's goofy. So my rectangular plane is not really rectangular. But that is what that circle would look like if I were to draw it with a center at 4, -1, and a radius of 5. That's how you would graph that guy. Here's another one. We'll go to another page. I'm not going to throw some paper on here. We'll just grab a pen. We'll say sketch x minus 2 quantity squared plus y plus 3 quantity squared equals 16. And this one, we know the center is at 2, -3, right? So looking at the signs here, and I know the radius equals the root of 16, which is 4. Now, this doesn't have to be a perfect square. If you had r squared equals 20, you would have the radius would be the root of 20, which would be 2 radical 5, and you would just find the decimal approximation in a calculator if that were to happen. Okay, just go find out what that is and then use that approximation, because you will see something like this in varsity. I know you will. So I don't want you to think that these are always going to be nice perfect squares. All right, so we're going to grab this guy, and we have 2, -3. So 2, 1, 2, 3, and then we're going 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3. Watch how badly I draw these if I try to draw them by hand. Well, that's not terrible. They kind of look a little eggish, sometimes footballish, whatever. But that is the standard form of a circle. They're pretty straightforward. All right, now let's introduce the general form. And I already said it's going to be ax squared plus by squared plus dx plus ey plus f equals 0. Now, there's a rule on this one where a has to equal b. So these two numbers have to be exactly the same in the general form. Okay, so when you see something like this, your job is going to be to put the general form into standard form, because you can't tell anything about the circle in general form, by completing the square. So we're going to walk through that here. We're going to start with the equation given 8x squared plus 8y squared minus 56x plus 16y plus 34 equals 0. Okay, we're going to put that into standard form. So to complete the square, there's some steps that you're going to want to follow. So to complete the square, and we're going to be doing this for every conic. So 1, we're going to group the x terms into a set of parentheses. Then group the y terms. A set of parentheses. And move the constant to the right side of the equal sign. Okay, so step 1, I'm going to take this guy and this guy. So we're going to have 8x squared minus 56x, and then 8y squared plus 16y. We're going to move the 34 to the other side. And so that one's always going to change signs. Okay, change my pen color so you can see what's happening. So step 2, we're going to factor out the numeric, only the numeric GCF from both quantities. And at the same time, leave a blank for the C term in a quadratic. Okay, so what we have in this first one, we have 8 and a 56. So, and we're only, I know there's an X here as a GCF, but we're only taking out the numeric part. So we're going to take the 8 out. We're going to leave the X squared minus 7X, and we're going to put in plus a blank. So that's for the C part here that we're talking about. Leave a blank for the C term in the quadratic. Here we're also factoring out an 8, y squared plus 2y plus a blank, because these are both quadratics, right? Ax squared plus bx plus c, ax squared plus bx plus c equals negative 34. And if I'm adding a blank into 2 different places on the left side, I have to leave a blank on 2 different places on the right-hand side to keep this equation balanced. Okay, so I got to scroll down a little bit for you. Don't worry, I'll come back. Okay, the next one, let's do something very different in color. Step 3, the blank is 1/2 of the B term squared. So this first one is a little gross. So this B term, right? These are in terms of ax squared plus bx plus c. So we're creating a C term. So we're going to take 1/2 of 7 and we're going to square it. Well, that's 7/2. We're going to square it. So that's 49 over 4. And that's going to go in that blank. Okay, this one's a little bit simpler. This one we're going to take 1/2 of 2 and square it. Well, 1/2 of 2 is 1. Squared is still 1. And that's what's going to go right there. All right, now you need to be careful on the right-hand side. On the right side, be sure the blanks are the coefficients multiplied by the left blank. And I'll highlight that so you can see what I mean. So in the X quantity, this number, the 8, is going to get multiplied by this 49/4, and that's what's going to go in this blank here. Okay? And the right hand, the Y quantity, this 8 is getting multiplied by this 1, and that's what's going to go in this blank here. Okay, so that one, the second one, the Y, that one's simple because we have a pen. So this guy in the Y, the 8 times 1, this is just 8. But this one is a little bit disgusting. We have 8 times 49/4. You can do this in a calculator. This is actually 98 is 2 times 49. So 98. Okay, so now the next step. And this will take a little bit of practice for you to get good at it. The math isn't really terribly difficult. The next step, 5. On the left, you need to turn the now perfect square. Because what you did was the C term that we made created perfect square trinomials into perfect square binomials. And the way you do that is you're going to factor that. It's going to be squared. And the first term is going to be the root of the ax squared term. The second part of your binomial is going to be the root of the c term. And then you're going to have a plus or minus, and that sign is going to come from the b term. Okay, so here's what's going to happen. We are focusing on this box right here. Okay, the 8 has to come down in the front. I have a binomial squared. I'm taking the root of that. Well, the root of x squared is just x. Then I'm taking the sign off the b term, which is a minus. And then I'm taking the root of that. Well, the root of 49 is 7, and the root of 4 is 2. So this is 7 over 2. Okay, now let's do it for the next quantity. I'm going to bring down the 8. Binomial squared. The root of y squared is just y. The sign off the b term is a plus, and the root of 1 is 1. And that's how you turn those trinomials into binomials. You guys can do that math. That's not very difficult. So you're going to, on the left side, do that. Turn your perfect square trinomials into perfect square binomials. And on the right, just add and subtract. So add or subtract, so that you have one number. Okay, so we're going to go negative 34 plus 98 plus 8. And I've already got that done somewhere. And that equals 72. Okay, you can stick that in a calculator and double check if you'd like. All right, now, because you can't have these leading coefficients of these 8s in here, and in the other quantities, we actually can't have, excuse me, a number on the right-hand side that's anything but a 1. You'll get that later. We need to, number 6, in this case, oh, that was weird. Let's put that back. So in this case, we need to divide out the coefficients, if there are any. Let me get rid of that. On the binomials. Okay, so we need to divide this by 8, divide this by 8, divide this by 8, which gives us just x minus 7/2 squared plus, because these cancel each other, these cancel each other, y plus 1 quantity squared. 72 divided by 8 is 9, and this is the standard form of our circle, with the center at 7/2, comma -1, and a radius of 3. Okay, so if we were answering this question, we would know that we have a center at 7/2, -1, and a radius equal to 3. All right, that's the only one of those I'm going to do as an example. You should have sufficient information to do the varsity on this. So toodaloo for now.